All right, guys, so the next topic is applications of graphing and finding equations. So it's basically taking the last two booklets and putting them together into word problems. So I'm going to do a couple examples from the booklet with you. We're going to start with example 3. At a seaport, the depth of the water, h meters at time t hours during a certain day, is given by the formula provided. So in the formula, a lot of the same things occur like A, B, H, and K. The one thing is that you may notice that t minus 4 is in a numerator here. So what I'm actually going to do is I'm going to rewrite this formula a little differently, making it look like something that we're used to seeing. So 1.8 sine. And instead of 12.4 being underneath the brackets, since it's multiplied together, I can put it underneath the other coefficient as well. So I can put 2 pi over 12.4 and then go t minus 4.00. And there's the 3.1. So now that might be a little easier in terms of finding period and those types of things. So remember that period is still equal to 2 pi over b, which in this question is 2 pi over 12.4, which would get flipped and switched, canceling out the 2 pi's, and your period ends up being 12.4. The amplitude is equal to 1.8, and the phase shift is equal to 4. But here's the catch. Because this is a word problem, we should have units in every answer that we have. So because x, or period and phase shift and those things, deal with t in hours, I always go back to the question, it could be minutes, seconds, whatever. It's hours in this case, then our period is 12.4 hours, and our phase shift is also 4 hours. And the amplitude is in meters because it deals with the y values, so it's 1.8 meters. So if I want to do a sketch is still going to follow a lot of the same stuff from the previous booklets. So I have the amplitude of 1.8. I also have the k value of 3.1. So being a little bit lazy with my tick marks, I can just put the middle at 3.1 there, and then minus 1.8, which would be 1.3, plus 1.8, which puts me at 4.9 meters. So you don't have to be super specific with your tick marks. Period is 12.4. Remember to do a scale in the x-axis. We're going to take the period and divide it by 4, which gives us 3.1. All right, and the phase shift is at 4, so I'm actually going to start my tick marks at my phase shift and then just go up and down by 3.1. Which gets me to 16.4. Okay, I have a sine graph. I need to start in the middle at 4 hours, and then I make my way up, middle, down, middle. And I follow the graph along just like so. The period should make sense because I'm from 4 to 16.4 hours, which is a total of 12.4, and that's my period as well. What's the max depth of the water and when does it occur? So the max depth is at 4.9 meters at 7.1 hours. And since it's 1/10 of an hour, which is 1/10 of 60 minutes, then we're at 7 a.m. and 6 minutes because that's 1/10 of 60 minutes. And then what is the depth of the water at 5 a.m.? The depth of the water at 5 a.m., we're actually going to take the formula again, and we're going to plug in 5 hours. So h of t is equal to 1.8 sine 2 pi over 12.4. When I'm throwing that into my calculator, make sure that I have extra brackets around my division. And then I have 5 minus 4. If you want to cancel that, that ends up being 1. So you could skip ahead and do something like that. And then we're going to add the 3.1. Making sure that everything is in radians. So we're in radians on the calculator. I go 1.8 times sine. Here's the extra brackets I talked about. So then that way I have 2 pi over 12.4 in brackets times 5 minus 4, which I don't need to put in there because it's 1, but just in case it was something else, double bracket to close, and I add the 3.1. So my depth at that point is equal to 3.97 meters. Okay, so you have other options in this booklet to look at throughout. So what I'm going to do is I'm just going to do one more here and figure out example 5's equation. Okay, so in this case we're getting onto a Ferris wheel. You have the diagram provided to you. It's 1 meter off the ground to start, okay, because that's the bottom of the Ferris wheel. So I'm actually going to draw a picture, even though you may notice that in the question it doesn't say to draw, it just says find the equation. But without the picture, it's going to make the equation more difficult because we need to figure out if A is positive or negative and where the phase shift is. So 1's the min. The diameter is 16 meters. So diameter goes all the way across. There's a question later where instead of diameter, it's radius. Okay, so just be careful because some questions do the radius instead of the diameter. If that was the case, the radius would get us halfway up, and then we need another radius to get us to the max. The diameter, though, gets us all the way up to 17, 1 plus 16, which means in the middle we are at 9. So our y scale is already done. The ride lasts for 4 minutes. The ride lasts for 4 minutes, so that is our period. So if the period is equal to 4 minutes, then the scale in the x direction is 4 minutes divided by 4, which means we're going up by 1 minute each time. So 1, 2, 3, 4. Okay, so 1 minute up to 4 minutes. Determine the parameters of the function, so we need to figure out where we start. In the question later in the booklet, it tells you that the people get on the Ferris wheel in the middle. If it doesn't say that, we're going to assume that the riders get on at the bottom of the Ferris wheel because that's pretty standard. So we're going to start at the bottom at 1, to the middle, to the max, to the middle, to the min, and now you have your brief sketch of the graph, and that should help you with your A and H value. Okay, so the amplitude in this case is equal to 8, also half of the diameter, which means that's the radius. Radius is amplitude when it comes to a circular question. The A value is going to be equal to -8 because we're going to start here at the bottom in terms of cosine. The H value is 0 because there's no phase shift at all. The K value in the middle is equal to 9. And the B value is equal to 2 pi over the period, which is pi over 2. So we got y is equal to -8 cosine pi over 2x. We have no bracket because no bracket in the middle here because there's no phase shift, plus 9. So every question in this booklet involves stuff that we've discussed in the last 2 booklets, but there's pieces throughout the puzzle, pieces throughout the word problem. So you're picking things out of the question like diameter being 16, which is 1 plus 16 to get you to the top at 17, etc. Right? So we're trying to make sure that we read the question carefully, underline the important points, take out important pieces of information, and then answer whatever the question is looking for you to do.